Hello, this is Ms. DB, and in this video we are going to review how to do mathematical induction in infinite geometric sequences. We are going to focus on the infinite geometric sequences part. The math induction will be an extra credit honors assignment for this folder. So our objectives are to find the sums of infinite geometric series. So in 12.4, you found partial sums of geometric series. You can also find the sums of some infinite geometric series. An infinite geometric series has infinitely many terms, and there's two things that could happen with that. In the first example, when we're finding the partial sums of the given terms, you can see that they're approaching a common number. So 1/2, 3/4, 7/8, 15 16, 31 32, 63 64, they're approaching the number 1. The other type is 1/32, 1/16, 1/8, 1/4, 1/2. Those sums are not approaching a common number. In fact, these are growing, whereas these ones are going to kind of end up at the same spot. So in the first example, 1/2 plus 1/4 plus 1/8, our common ratio is 1/2. In the second example, our common ratio is 2. If you multiply 1/32 by 2, you get 1/16. And if you multiply that by 2, you get 1/8. And that's the key right there. Here's an example of the first series, and you can see they're approaching 1. And the second one, it's growing and growing and growing. So what it is that when your common ratio, the absolute value of that, is less than 1, then we say that this series converges, and we can actually find the sum of it. It's approaching a limit. And you're going to learn a lot more about this in especially calculus, a little bit in pre-calculus, but really in calculus. But a limit is the number that it's approaching. It's kind of like an asymptote. In the second one, this is going to continue to grow. We're not going to be able to find the sum because it's going to get bigger and bigger and bigger. This is when r is greater than 1. So that's called a diverging series, or it is said to diverge, and we cannot find that sum. So you would just say, cannot find the sum, or it diverges. So the first type of examples we're going to do is just telling whether or not they converge or diverge. Remember that if they converge, then we're going to be able to find the sum, which we'll do next. If they diverge, we're not going to be able to. So in letter A, we have 10 plus 1 plus 0.1 plus 0.01. So our first task is to find the common ratio between those terms. Remember that ratio, we have to divide this term by the term before it. So that would be 1/10, or you could write that as 0.1. In the next one, let's just do a couple more. 0.1 divided by 1 is also 0.1. So it looks like the common ratio is going to be 0.1. So this one is, since r is equal to 0.1, which is less than 1, 0.1 is less than 1, then this is going to converge. In B, our common ratio, let's see, 12 divided by 4 is 3, and 36 divided by 12 is also 3. So our common ratio is 3, which is greater than 1. So this example would be a diverging series. Oops, where did A go? There it is. This is just another example, two more examples. So in the first example, remember to find the common ratio, you take a term and you divide by the term before it. So 1 divided by 2/3. Well, that's the same, 1 divided by 2/3 is the same as 1 times 3/2, which is 3/2. Let's see if we get the same thing. Oh, the next one's easier. 3/2 divided by 1 is 3/2. So our common ratio is 3/2. That's greater than 1. This is a diverging series, and it's not going to have a sum. We're not going to be able to find a sum. It's going to grow. In the second one, 16/32, that's 1/2. 8/16, that's also 1/2. 4 over 8, that's 1/2, 2 over 4. So in this one, our common ratio is 1/2, which is less than 1. So therefore, we would be able to find the sum of this series. It will converge. All right, here's your examples from your worksheet. Let's look at number 2. In 2, how did we get from 1/16 to 1/8? What did we multiply by? One way to find out is to write it as a ratio, 1/8 divided by 1/16. That's the same as 1/8 times 16 over 1. And 16 over 8 is 2. And you can check 1/2 divided by 1/4. We could do it this way too, it's a little faster. That goes in there 2 times, so this would be 2 over 1. So our common ratio is R equals 2. Now that is a number that is greater than 1. So therefore this diverges and there will not be a sum. Number 3, I think, will converge because these are getting smaller and smaller each time, which is a good hint that this is a converging series. So you'd need a calculator on this one. We'll take 8.8 divided by 35.2. And I grabbed my calculator here, and 8.8 divided by 35.2 is 0.25. Let's check. 2.2 divided by 8.8, that's also 0.25. Should we do with the next one? 0.55 divided by 2.2. It is. It didn't look like it would be, but it is. So our common ratio is 0.25, or you could write it as 1/4, which is less than 1, which means that this is a converging series. So if we have a converging series, if you determine that, then we can find the sum. There's going to be a formula, and this is how they came up with the formula. They did the partial sum for a geometric series with a sub 1 equals 1/2 and r equals 1/2. And they wrote it like this, and it's really long, but it simplifies with some magic math. This is all algebra skills. It simplifies to this, which led the mathematicians to figure out that you could use this formula, which is a pretty simple formula. You first have to make sure that the absolute value of r is less than 1. That means that r could be negative 1/2 or positive 1/2 because both of those have an absolute value less than 1. And a sub 1 will be the first term, and then we just do 1 minus, that's supposed to say r to the, well, it's just 1 minus r. So the formula is just s equals a sub 1 divided by 1 minus r. So your first step is always going to be to find r. So in this example, they found r already, and they got negative 0.2. So that will go for r. A sub 1 is 1. So we replace the a sub 1 and the r, substitute in, and simplify. Be very careful of simplifying that you don't mess up on the minus and negative. That's the same as plus. So 1 plus 0.2 is 1.2, and then use your calculator. And this is the sum that this series will converge to. You can check it by graphing the points and see that it's going to end up at about that spot. Okay, hey, let's look at another example. First of all, we have to determine if r is less than 1, the absolute value of r. And it is because it's 1/2. So r is less than 1/2, so the sum is going to exist. Now we're going to use the formula. The formula is that we need to know what the first term is. And when it's in summation form, we don't know the first term right away. So we have to plug k in right here, or 1 in for k, and we'd have 1/2 to the 0, which is 1. Anything to the 0 power is 1. So a sub 1 is 1. And then we plug that into the formula. Here's where the 1 goes. The r is down here. 1 minus 1/2 is 1/2, and 1 divided by 1/2 is the same as 2. So this will all converge to the sum of 2. And again, there's a graph that supports that. Just another example. Practice this one on your own and then come back, pause the video, and then come back and check your answer. All right, so you should have first found r, and you should have found that r is negative 0.2, which is less than 1. The absolute value of that is less than 1. So then you're ready to use the sum formula, where you plug in a sub 1 is just 25 in this case, and you'd get 25 over 1 plus 1.2, which is 1.2, and then you use your calculator. So you could either have your answer this way or this way, depending on how you decided to leave it. And that's the sum of this series. Here's an example from your worksheet. You first have to find a sub 1. So we need to plug in k equals 1 by putting 1 up here. So that would be 4 times 0.5 to the 1 minus 1 is 0. Anything to the 0 power is 1, so we would have 4 times 1, or 4. The next thing we need to do is find r. So to find r, you could write out your series and then, for a few steps, and then you could take one term, divide by the previous term, but when they write them in this form, that's the r is right there, it's 0.5. So r is 0.5, which is less than 1, so this is converging, so then we can go ahead and use the formula, which is a sub 1, which is 4 over 1 minus r, which is 0.5. So we would have 4, whoa, I keep hitting a button here. We'd have 4 over 1 minus 0.5 is 0.5, and you can use your calculator if you want, but that's the same as 4 divided by a half, which maybe you realize is 8. So this sum is going to be 8. Here's number 9. In number 9, our a sub 1 is already given, so our first step is to find r, and r will be 4 over 25 divided by 2/5, and then you have to simplify that and find r. I'm going to multiply top and bottom by 25, the common denominator of those two fractions, and I'll get 4 over, 5 goes into 25 fives, 4/10, which is the same as 2/5. This is less than 1, so our series will converge, and we can go ahead and use the formula then. And the formula is a sub 1, which is 2/5, divided by 1 minus 2/5. Well, let's simplify this. 2/5 is going to stay on top, or you could change that to 0.4, but 1 is the same as 5/5. 5/5 minus 2/5 is 3/5. And now I'm going to multiply top and bottom by the common denominator of 5, and I will get 2/3. So the sum is equal to 2/3. Now there's other ways to divide these. You can take 2/5 divided by 3/5, which is the same as 2/5 times 5/3, which gives you 10/15, or 2/3, so you get the same thing. Or you could change them to decimals. All right, the next thing we're going to do is we're going to apply this to writing a repeating decimal as a fraction. So you've looked at repeating decimals before. What we're going to do is turn that into a fraction, which is not a skill that you've had before we learned this. So we're going to start by writing 0.63 repeating. First, you just write it out a ways, 0.63, 63, 63, ... which is the same as 0.63 plus 0.0063. I had to put 2 zeros here because I want to add these two together and get this. Plus 0.0000, 4 zeros because there's 4 digits here. Plus, and then it would continue. So now we wrote this as a series, and if you add this together, you'll see you get exactly this, which is the same as this. So we need to find the common ratio. To find the common ratio, you take a term, divide by the previous term, and you can check that on your calculator, but that's going to be 1/100th, or 0.01. And you'll see there's going to be a pattern to this common ratio. That is less than 1, so we can go ahead and find the sum. That's what we're going to do. We're going to find the sum, and that will lead us to the fraction. So we plug in the formula. A sub 1 is right here, 0.63. Not repeating, just 0.63. The ratio is 0.01, so we take on the bottom 1 minus 0.01, and that's 0.99. Now right here, you have to simplify this. You can't just do it on your calculator or you're going to get this. So pretend that, let's multiply 0.63 and 0.99. Multiply both of these by 100, which is the same as 63 over 99. Now simplify this fraction. It's certainly divisible by 3. Let's see, what else? It's divisible by 9. Both of them, you can divide both of them by 9. So you need to simplify your fraction, not just type it into your calculator, unless you have you can simplify fractions on your calculator. And that's how they get the 7/11ths. Now that's what we're trying to find, is that fraction right there. And you can double check this by just using your calculator, taking 7 divided by 11 and making sure you get 0.63636363, which this shows that you do. Now your calculator rounds at the end, so that doesn't mean that that's the same as 0.63 repeating. It's just how your calculator handles that. Okay, so let's try this one. This one only has one digit that repeats. It's a little bit different, 0.11111. There's only one digit that repeats. So you write 0.1 plus 0.01 plus 0.001. So here's the 0.1, here's the 0.01, here's the 0.001. And then we're going to go ahead. This is, I'm going to go back a step. This is our first term. We next have to find the common ratio. So you just take one term, divide by the previous term, and we get just 0.1. Remember that in our other example where we had 0.636363, we got 0.01 for the common ratio. So you'll find that every time you only have one digit repeating, 0.1 is going to be the common ratio. This converges, so we're going to find the sum, which will be the fraction. So our first term again was 0.1. We're going to take 1 minus 0.1, and that is 0.1 over 0.9, and just multiply both top and bottom by 10, and you will get your fraction 1/9. Because we don't want to leave our decimals in the fraction like that. There's a couple of these on your worksheet. There are some where you repeat one digit and some where you repeat two digits. So the first step is, I'm going to do this number 13, is to write this as a series. So this one has 2 digits repeating, so I have to add 2 zeros. You don't want to cover up the other numbers if we were adding these vertically. And now I need to find, this is a sub 1, I need to find the common ratio, which would be 0.0083 divided by 0.83. And you might guess that your ratio is going to be 0.01. I'm double checking on my calculator. And it is. So now I'm ready to use the formula right here. S is equal to 0.83 a sub 1 over 1 minus 0.01. And 1 minus 0.01 is 0.99. And this is 0.83. Now I'm going to multiply top and bottom by 100 so that I don't have the 2 decimal places there. So that's 83 over 99, and then we need to see if we can simplify that. You can't divide either of them by 3 or 9 or 11, so then this is our fraction if you can't simplify. I don't know why that got so messed up. So 83 over 99 is the answer for number 13. All right, well, good luck. Let me know if you have any questions, and have a great day. Thank you.